Alright, third time's a charm, they say. I was recording this, I was several minutes in, and then I realized my mic was muted, so I had to start all over. On the second one, I kind of rushed through it to try to cover the same ground, and I ended up leaving important shit out. So let's start all over. Alright. I have been working on a video for about 4 months now. Maybe longer, maybe, I don't know, time kind of slips away from you. I started it while I was still doing the buttocks to colon transition for version 0.2 to 0.3. And that video was supposed to be covering a lot of ground, talking about a lot of things that if you've been following this channel for a while, you're already familiar with. The sprite layers, the tile layers, all of that. And I realized while making that video that the engine has changed so much over the past 4 years that a lot of what I was talking about was no longer relevant. Ideals have changed. Um, and a lot of the core audience to my channel already know what I was talking about. So going over the same thing over and over again would be a really long video that almost nobody cared about. So I'm thinking I'm probably going to just go ahead and stop working on that video. There were parts of it I really liked, but it really just doesn't offer anything that anyone's going to want to sit through 40 minutes of. But in this video, I'm going to talk about the one thing in that video that I did cover that I haven't really talked a whole lot about anywhere in one single setting. I think I've covered bits and pieces of it over several videos, but I'm going to cover all of the different branches that have started since the beginning, what was added at those, and where I am right now. Starting at the beginning, we have ANUS 0.1. That was where I developed the protocol. I had planned out all the features the system was going to have, and I built everything as a prototype on top of Raylib. Now, Raylib is a wonderful library. If you're going to build a game and you don't want to use an engine, Raylib all the way. Way better than SDL in a lot of ways. In my opinion, that's just an opinion. But to me, if you're going to develop a game and you don't want to use an engine or you want to develop your own engine, Raylib is absolutely the way to go. The thing about Fuselage is, though, it's just not really a game engine. It's meant to be a framework for a virtual machine. And there's a big difference because if you're building a game without an engine, you're going to need certain key features that Raylib provides. Many of the things that Raylib provides, I won't be needing for the virtual machines. So if I had used Raylib, I would have ended up with a much larger, more competent, more complete library, providing features that would have been nearly impossible to access from the virtual machine side without putting a lot of work into the engine. And then really I wouldn't have an engine, I would just have a abstraction layer, a wedge or a wrapper for the VPU to access the Raylib features. Might be useful to have that, but that's not really what Fuselage was meant to be. Fuselage was originally designed to be a virtual machine that gives us a dream console, a video game system that could have existed around the year 2000 or so. I wanted to provide game developers a platform, a stable, non-moving target that they could make their games for, knowing the performance that they would have on hand. It's kind of like when you see modern game developers making games for retro systems like new releases for the Sega Genesis or the Nintendo 64. This is a thing that happens. People are making new games for the Neo Geo. People are making new games for the Amiga. They are a fixed target. They know what the performance constraints are, and they work within them to create the games that they want to create. Now, we have a lot of modern game developers that are making modern games on modern platforms like Windows and PlayStation. And if you look at the games they're creating, they're great games. Take Silksong, for example, or that one Hollow Rat game that just came out. All of these games could have existed on systems we've had long ago. So what they ended up doing is creating these games on modern engines, Unreal or Unity or Godot or whatever, and they're much bigger and more bloated than they need to be. What we really need, in my opinion, and people will disagree with me on this, is a game engine that caters to a certain development crowd that wants modern tools and they want to publish their games on modern platforms, but they don't want big bloated engines that offer things that they don't need for their game. Fuselage is kind of trying to target that market with some unique twists. one of the things I wanted to aim for was developing games for RISC-V that play on all of the major platforms. Now, when I designed the protocol or the framework or the API, ABI, whatever you want to call it, around Raylib, it was with the intention of pulling Raylib out from underneath it and replacing all of the subsystems with my own. The first of those was GDMF. That was your sprites, your tiles, and windowing and rendering with Vulkan and handling all of those things. And this was a major undertaking. This actually happened in 0.2 buttocks. When I pulled Raylib out from underneath it, I lost keyboard, mouse, joystick, I lost sound, I lost rendering. So I had to create a windowing system for Windows, Linux, and Mac. I had to create a rendering system using Vulkan, and I had to create an input system, and that was Cake. That came in around the end of buttocks and in the beginning of colon. Cake was the input layer that takes your joypad or your mouse or your keyboard and translates it to whatever operating system you're on. It's an intermediary layer, and it's still far from complete, but it's usable on all three systems, and it allowed me to continue further development in other areas. After that, I had to implement a timer system. All of the three systems handle scheduling different, and it meant creating a single interface that no matter what platform you were on, your application could get access to things like frame rates and elapsed time and random numbers and random number sequences and deterministic number sequences, and they needed to be consistent between all three platforms. So I've done my best to try to make those facilities available through DICE. And after DICE, we came to the VPU. This was what prompted the move from colon to DERRIERE, because the VPU is probably what puts us in the area where I wanted to be from the very beginning. This is where we leave the whole developing a application on each platform and creating a virtual machine where we can develop applications for the virtual machine instead of the host. Now, you can still use each individual framework on their own. Cake and DICE and GDMF can all be used independent of each other. You do not need to use the whole system. You can say, I just want an input handler, and use Cake all by itself. In fact, I've done my very best to make sure no subsystem is aware of any of the others. Fuselage is the orchestrator that binds them all together, but no system relies on any part of the other. In fact, that came up as an important detail later on when I started designing Sharp, because Sharp needs very precise timers. Well, how do I provide Sharp timers without giving it access to the operating system timers, or without using DICE, because it can't know about DICE? Do I pass timer information down from Fuselage? Well, sound is very timing important. I mean, you have the risk of buffer underruns, and you have the risk of missing your scheduled, buffer rendering. So Sharp had to have its own timers for each operating system, which meant that I had to re-implement some of the things I'd already done in DICE in Sharp, which was two different systems using the same features. Now, in other engines, they would probably just rely on the same feature for both, but since I had to keep Sharp and DICE separate from each other, it meant re-implementing some of the similar ideas. Which is fine. It's fine. The important thing is, though, that no system in Fuselage relies on any other part of it. When I created the VPU, the idea was going to be that a program written for the VPU would be written in RISC-V, and there's a interface I call MISL, the Machine Independent System Language. It's actually more like a Machine Independent System layer. It is a set of eCalls and memory-mapped I/O ranges that the virtual RISC-V processor uses to talk to Fuselage. All of the features of all of the systems are mitigated through that set of eCalls and memory-mapped I/O range. The VPU itself is completely unaware of Sharp, DICE, Cake, GDMF. It doesn't know any of that. But the memory-mapped I/O ranges are handled by Fuselage. So it delegates all of the things that the VPU wants to do, and the VPU simply knows it's making a call into this IO range or making a call to this eCall. And this gives you all of the features of Fuselage to the VPU, which is, by the way, just a generic RISC-V processor. It does have floating point and double precision math, but there's nothing special about it. In fact, it's as vanilla and by the book as it can be, but it passes all of the RISC-V, the corpus of tests to make sure it's compliant. So even though it is a very bare bones vanilla RISC-V processor, you can use the standard RISC-V development tools to assemble or compile C source code and create an application using the missile layer to address all of the features of Fuselage, which means you can write a program one time, create a rope, a run on any platform, and it will run on any system where the missile launcher has been ported. Now, I want to get to that right now. One thing is the missile launcher itself. When you develop an application for Fuselage, you can make a native application for the system you're targeting. So let's say you want to make a game on Windows. You can use the Windows frameworks provided by Fuselage to make a game that's a Windows native application. It doesn't have to be cross-platform. It would be really easy to make it cross-platform if you use nothing but Fuselage. But if you start doing things like loading files and managing your own save states and all of this other stuff that you're going to be adding on every individual system, you're going to run into all kinds of problems porting your game between systems. If you leave access to OS specific stuff out, your game becomes 100% portable. And if you make the game using the RISC-V tools and you build an embedded application, then your same application should build identically on Windows, Linux, and Mac. This, I think, will be the great appeal for game developers who want to sell their games on major stores like Steam or GOG or itch.io, but don't want to just distribute a rope. You don't want the end user to have to launch it through a launcher because that looks unprofessional and it's confusing. And plus, there's the whole, well, I mean, if they just download a single rope file, then they're just going to pass it off to their friends and whatever. And maybe you don't mind that. That's fine. But a lot of developers want to encase their distribution in a certain platform such as Steam, and they don't want their game just being some loose file like that. If that's the case, then you can embed it and do all of your Steam related things and have a self-contained Fuselage application that might under the hood still be RISC-V but still be tied to whatever ecosystem you plan to distribute it through. I would prefer people get used to just writing ropes. And it's because this engine isn't just for game development. I mean, it is primarily a game-centric platform, but a lot of people will want to play with developing using RISC-V, and rather than just using a generic terminal and doing number crunching and basic printf type console applications, they might want to see a sprite move across the screen or move a tile layer or play with graphics. Developing and learning RISC-V through Fuselage will be really appealing to students and hobbyists and the demo scene people. There's a certain crowd that I think will want to experiment with low-level development that up until now have been really ill-served in the modern era. I mean, we do have things like Pico 8 and stuff like that, but when it comes to learning assembly or doing really low-level game development, you've always had a choice between not really getting good modern visual results or targeting really old platforms like the Super Nintendo or the NES or the Game Boy. And I think Fuselage is going to fill that niche. It's going to give people a somewhat modern platform to get instant results from. So in the not-so-distant future, I'm going to be releasing the launcher and a disassembler, and also a machine language monitor. So you should be able to sit down with the RISC-V development tools, the suite of compilers and assemblers, create a rope and run it, and see your results instantly on the launcher. Now, in addition to those tools that are coming very soon, I'm also going to be creating a long series of demo applications, but they're not like some of the demos I've done already. These are going to be a lot more focused. One or two features of Fuselage, and that's it. So you're going to be able to look at the source code and say, oh, that's how I allocate a sprite, or that's how I scroll a tile layer, or this is how I do a pixie mask, or this is how I do a pixie chroma key. These things will be documented in a piece of source that is pretty much single shot, one or two features, well documented, so you can learn the whole API while you're getting used to either doing things in assembly with RISC or C in RISC. Or if you want, you can compile them native on Windows and get a single exe that does that. If you want to develop standard exes for Windows, Linux, and Mac, that's perfectly fine, perfectly valid way to develop with Fuselage. But the whole virtual machine angle was one thing that Fuselage offers that I don't think has been widely available in any other form, at least that I know of, and isn't constrained to things like Pico 8 or anything like that. Now, there's no shortage of game engines. I mean, if you wanted to make a game, you have Game Maker and RPG Maker and Godot and all of these other systems that are probably better suited for a modern game, if you will. But Fuselage is offering a virtual platform, a target that anyone can develop for and know what the end result is going to be on anybody who tries to run it on their system. So if you develop a application using RISC-V, you have a pretty decent guarantee that no matter where the person tries to run it, if it's modern enough to run Vulkan, it's going to be powerful enough to emulate the RISC-V processor that I've implemented. It's not a terribly powerful processor in the emulated form, though, as a funny side note, I've noticed that the Mac Neo emulates it really well, which was surprising to me. Some of my more modern, powerful desktop x86 machines struggle with some of the demos that I've done that are heavy on the floating point and double precision math, and the Mac Neo just chews right through them. So I don't know if it's because ARM and RISC are so similar compared to x86 and ARM, which are very different, and of course x86 is very different from RISC-V. Basically what I'm saying is I think that the Apple Silicon chips are closer to the RISC-V in nature than the x86 is to either one of them. So as a result, the translation just seems to work a little bit more efficiently. And I was pleasantly surprised by the performance of the Mac Neo. I'll just say that. But no, you should have a pretty decent guarantee that whatever you write for Fuselage using the virtual machine should run pretty well on any machine that can actually run it, which would be pretty much any modern machine with Vulkan drivers. So ENTERON is where I'm at right now. I've left DERRIERE. I'm still kind of cleaning up the source code for the various branches and trying to get them puked up on GitHub, but I really should just kind of chop those branches off because they represent a state of the development that's incomplete and completely deprecated now. Now ENTERON adds a library. We have a single library file and a header that you can use to build your applications against if you're making a native application. We have a virtual machine that is a launcher that you can use to launch your ropes from. And we have a build process for building the launcher with the embedded rope inside of it if you want to develop a rope and then just embed it in an application for distribution. That's perfectly fine. One benefit of doing that is if you had built a rope and you embed it in an application for distribution, you can immediately do that on Windows, Linux, and Mac. But what if in the future somebody ports the missile launcher to another system that either isn't even around right now or one we're not even thinking about, like, say, Nintendo Switch? Well, if you develop a game using the VM, when the Switch version becomes available, you just bind it in a build with the launcher, and boom, you now suddenly have a game that you can sell on the Switch. I have no plans to port Fuselage to the Switch platform, but it is free and open source, so there's nothing stopping anyone from making a build on another platform. As long as the ABI is honored and nobody makes changes to the actual virtual machine itself, then an implementation on another system should just automatically adopt the ropes that already exist going forward. Now, each launcher that I've built so far does check against a certain version, and certain older versions of the ropes are rejected either because the API has changed or because there were some problems with the way things were done. Earliest versions of rope did not have floating point or double precision math. Newer ones do, so obviously newer ropes would not run on the older launchers, but since some of the APIs changed, older ropes won't run on the newer launchers. Now, by version 0.8 or 9, I plan to lock the API. So by version 1.0, we should have a pretty stable interface that doesn't change very much going forward. So it should be easier to compare the current launcher to older ropes and see whether or not they should be compatible or not. But at some point, I'm going to lock it all, and you should have a pretty reasonable guarantee that anything you build today would be running by then. Well, I say today, but by that point, because we're still in what I consider an alpha phase, and anything built today won't be guaranteed to be compatible when 1.0 release reaches. But at some point, I will be locking the API so that if you build games using Fuselage, they will be pretty well guaranteed to be forward compatible. That's still probably several versions away. Like I said, we're on ENTERON right now. I'm about ready to release the launcher in its alpha stage and a bundle of ropes to play it with. And you can expect to find that either on my Patreon or GitHub. Probably both, one or the other, I don't know. But development's moving pretty fast, so one of the things I've kind of held off on doing is releasing stuff too early, because what I put out today may not represent what you're going to see in a week from now. Now, I never meant for development to go that fast, but once the VPU fell into place, everything just started locking into place, and development grew exponentially. Some of the systems I've been working on for months suddenly had a place to land, and I was pleasantly surprised with how well things started moving once the VPU was done. Oh, I say done. In a working state. Nothing's done. Everything is a work in progress. But, yes, basically what I'm saying now is, now that we're getting a 0.5 ENTERON, you are going to start seeing stuff you can actually play with. The library is going to be on GitHub as a lib file for... well, it'll be a DLL in Windows, a .a file on certain... I guess, wasn't that what DynLib is what Mac OS uses, .a's, I believe, what Linux uses. But it'll be a statically linked library for all three platforms with a header file. And I'm going to have to put together a document telling you the tools you need to build an application. And at that point, if you know C, it should not be a problem. The API is pretty well... laid out. I need to make a good cheat sheet for all of the functions. All you have to do is basically manage your main execution loop. The actual main of the program itself is called from Fuselage. So there's going to be a body. Right now I've been using the function named game, but that's going to change, I think, here real soon, because it implies that you're making a game and you may not be. Program, maybe, or I think body is what I'm going with. Body, the body of your program, kind of drawing from HTML. So I'm thinking body will probably be the main function that you work with. Main is, it belongs to Fuselage. You do not do any rendering. You do not do any of the synchronization. All of that stuff's handled by the engine. All you do is your main execution loop, which means you've got to handle making sure your initialization's done, tracking that initialization. Don't call that again at the beginning of the next loop. There's some conventions to follow, but you don't have to worry about anything. Once you set a bitmap for a sprite, once you assign a sprite a palette, once you turn the sprite status to active and visible, it's going to be on your frame until either you change something or move it off the screen, or, well, until the program ends, basically. Everything in Fuselage is a state machine. So the tile layers, once you assign the actual elements of a cell, the bitmap to the tile type, and you place your tile map full of cells and palettes, it's going to do whatever you say, and it's going to continue doing it until you make a change or give it a new command. If you put it on the screen, it's going to stay there until either you hide it, or you scroll it, or you zoom it, or whatever it is you're going to do to that tile layer. It's going to remain there the whole time, and you never have to make a single call. The only call you will ever have to make is a change to it. So you have to kind of think about your game loop in terms of Everything that you send is going to a state machine, and you simply modify the states of the machine with your game logic. And so you're essentially going to be developing games on modern machines the same way you would have on an old retro game console. If you've got experience with that, you should be all right. Now, the VPU does take some getting used to on some of the things that it does. I mean, it only has so many cycles per game tick, if you will, before it has to give up control back to the main actual engine. So you do have to plan for the limited constraints of your virtual machine, but with a little bit of planning, you can work around that. It's actually a pretty powerful system. It's just like developing for a RISC-V core that basically your game loop is going to run inside one iteration of that BPU, and if it gets cut off midway, then your game logic will stall, and shouldn't be a problem if you're not trying to do impossible things in a single loop. But yeah, it is a change in how modern game engines run. So just keep that in mind if you ever decide to start playing with the VPU. Anyway, that's all I've got here. We're on ENTERON. Everything that you need to build an application should be either documented or available here very soon. I say probably within the week. You know what? I don't hold me to that. I don't. It'll be ready when it's ready, but it's almost ready. So keep an eye out for that. That's all I've got for now. So I'm gonna go to work, and there won't be any beer, but there might be some sausages. Later.